That means we started, guys. So what we're doing today is plotting complex numbers on a complex plane. The first thing that you're going to want to do, other than draw an axis out, is to label the horizontal axis as the real numbers and label the vertical axis as an imaginary number line. It's an unfortunate label. It kind of betrays that they both are equivalent number lines. They both have a positive direction. They both have a negative direction. They both have an origin. It also implies that there is one number that is both real and imaginary. And that would be the origin of both. And if I look at any number, one of the things that you are concerned about typically is a number's distance from zero. We've called that the absolute value of a number before. Let's look at this number right here. It has coordinates of 2, 1. And one of the things we're going to be doing with complex numbers is instead of expressing a number as an ordered pair, this is an ordered pair, there's a particular order to the numbers. 2, 1 is different from 1, 2, and that's what makes it ordered. Pair, because there are two numbers, that's ordered pair. I want to take the ordered pair and I want to express it as one number. Because we can multiply single numbers, we can square single numbers, we can use them in operations that we can't do when they're split apart into two numbers. So that number that we're going to express this as is going to be the real part of the number, which is 2, plus the imaginary part of that number, which we're going to express as 1i, or I. This is the number 2 plus I. They are distinct and separate. I won't be able to add 2 and I because they are not like terms. But I can work with 2 plus I as if it were a single number. This single number is made up of a real part, which we're going to call A, and an imaginary part, which we're going to call B, and all complex numbers. Numbers that occur not only on the real and imaginary axis, but can occur anywhere in here. All of them can be expressed as A plus BI, where A and B can be both positive or negative. This number 2 plus I can be thought of as the ordered pair 2, 1, or it can be thought of as the complex number 2 plus I. Now, I said we concern ourselves a great deal with what the absolute value of a number is, that number's distance from 0. If I'm looking at this number, how far away would this number be from 0? That would be more than 2. 2 plus I is its location. It would be the square root of 5. Are we forgetting a Pythagorean theorem here, where I'm going over 2 and up 1? 2 squared plus 1 squared, square rooted. Let's not forget that if we have a right triangle and a side length of 2 and a side length of 1, that this right here is the square root of 2 squared plus 1 squared. But I'm not going to write radical 5 here. I want you to keep that in the back of your head. I want you to see this as a location. Now, what I want to do is I want to take this 2 plus I and I want to rotate it 90 degrees. We actually talked at length yesterday about an operation that lets you rotate a point 90 degrees. What operation lets you do that? Yep. Like, get more simplistic, not just squaring, multiplying by. Remember, yesterday we said that multiplication by I is a 90-degree rotation. And multiplication by -1 is a 180-degree rotation. You remember those? So let's see what happens when I take this multiplication by I, 90-degree rotation. I'm going to move this down here, and we're going to do that to 2 plus I. 2 plus I, and we're going to multiply it by I. Well, this distributes. 2 plus I times I is 2I plus I squared. But I squared is -1. And if I reorder this, I get -1 plus 2I. And I'm reordering it so that it matches A plus BI. What ordered pair does that correspond to? How far left or right, and how far up or down? 1 left, 2 up. -1 plus 2I goes left 1 and up 2. That's my new location. This is now the complex number, -1, smaller marker, -1 plus 2I. And if I draw from the origin to that point, guess what that angle is? Would you agree that that point is the same distance from the center as the other point was? So I have taken this and I have rotated it 90 degrees by multiplying by I. How could I rotate the 2 plus I point by 180 degrees? Yeah, multiply by -1 or multiply by a second I by the previous point. The easier of the two would be to multiply the first point by -1. So I'm going to take this and scooch it on down here. Multiply by -1 is 180-degree rotation. I get -2 minus 2I, or minus I. Which ordered pair does that correspond to? -2, -1. And when I actually graph that, oh, not there, -2, -1. Don't I have a 180-degree rotation? I'm going to let you guys get the fourth point if you want to rotate it one more time. But let's not rotate it one more time. Can I go backwards from that point and rotate 90 degrees the opposite direction? Divide by I is 90-degree rotation clockwise. You will never remember what CW means unless you write the word clockwise years from now. No, this is going to be 2 plus I, and I'm going to go divided by I, and let's see if that actually gets me a location that is 90 degrees backwards. Well, shoot, 2 plus I over I need a way to get this I out of the denominator. Numerator, denominator by I. This is not rationalizing, which is a word that means to make rational. This is realizing, a word that means to make real. So 2I plus I squared over I squared. That's a lot of I squareds, unless we make this 2I minus 1 over -1. And dividing by -1 is the same as multiplying by -1. That's going to become 1 minus 2I. Or the ordered pair, 1, -2. And that puts my point down here, which completes my little rotation of axes of all these different places. This is one of the aspects of just simply multiplying by I and dividing by I. This doesn't even cover what it means to multiply two complex numbers together or divide. That's something that we're going to start now, but we will extensively cover in Pre-Calc 2 when we actually talk about translating coordinate systems into a different coordinate system. But to kind of go back and address a question, most of the time we don't actually talk about points as XY points. We talk about them as what angle do they make from 0 and how far away is that point from 0. That's what's called converting a rectangular coordinate system into a polar coordinate system, one that deals with angles and one that deals with radii. So tiptoeing onto a field of mathematics and a lot of applications in both math and physics, we use complex numbers to create this case of where these numbers are truly mapped as two-dimensional numbers. They're not just single-dimensional, and they expose possibilities that we couldn't do otherwise. Now we need to do some basic operations with these. So we're going to do some examples where we multiply and divide. You guys still need to be able to work with these numbers using the tricks that we've learned. But then we're going to get to some more complex problem types that you can feel ready for tonight's homework. So we're going to start with this, a multiplication operation, and then a division operation. I'm going to try to do it vertically, but remember I can always move it down like that because, yeah. So what am I thinking of with these? This is just as simple as doing what? Well, first 12 outer plus 6i inner minus 4i last negative 2i squared. But negative 2i squared is just negative 2 times negative 1, which is just plus 2. And my complex number would be 14 plus 2i. If I asked you to plot that onto a grid, first you'd hope that I gave you one that had 14 boxes to the right, or you were rescaling. But you would know where that would go, right? Not that you can actually plot it on everything, but you have an idea of where it would go. Yes, Jay? Oh, you don't want to. And the reason why is because if you factor out the 2, then you no longer know where that ordered pair would go. You're trying to say that this is the ordered pair 14, 2. Now, if I was dividing it by a 2, yes, of course, we could factor in 2 out and do that. How do I do this one? This is actually division, but how do we divide? Multiply by the conjugate. Negative 1 plus I, negative 1 plus I. Because multiplication by a conjugate allows me to get that thing out of the denominator. I will have people tell me that this simplifies to negative 3 plus 4i. Do not do that. They divide the reals, they divide the imaginaries. That's not how fractions work. So we get the first, negative 3. Outer plus inner gives me 3 plus 4, or plus 7i. Last is minus 4i squared, divided by denominator. Negative 1 times negative 1 is 1. Outer and inner cancel each other. That's why we did the conjugate. And I get 1 minus i squared. Guys, write the step where you make it I squared. You're going to make some sign mistakes if you don't do this first and then make I squared be negative 1. It's not worth it. I'm going to do one more step now where I just replace I squared with negative 1 and then multiply it. So minus 4i squared becomes plus 4. 1 minus I squared becomes 1 plus 1. My numerator now becomes 1 plus 7i over 2. But this is not in a plus bi form. It's a plus bi divided by a number. Because I need to know where this number is going to plot, I want to split this. 1/2 plus 7/2 I. I do that because I want to know that when you plot it on an axis, we're going to go 1/2 right, 7/2 up. That's why we do that. Yes? Well, I can't multiply by 2 because that would change the whole value of the fraction. I'm not solving for anything. Okay. I'm simplifying. That's like saying I have 3 over 2. Why don't I just multiply that by 2 and make it 3? Well, then you change it. Okay, next example. The reciprocal of the conjugate of 1 minus 2i. Heavy in the prepositions, huh? Because two ofs. With on for after at by in against instead of near between. Okay, back to this. Reciprocal of the conjugate. So what is the conjugate of 1 minus 2i? So this is just asking for the reciprocal of 1 plus 2i. And how do you reciprocalize a number? Yeah. So I flip it. When you flip it, you have to flip the whole thing. You're doing 1 over 1 plus 2i. So now this is translating to another question. How do I get this into a better form? So my numerator becomes 1 minus 2i. The denominator becomes 1 minus 4i squared, which is the same as 1 plus 4, which is the same as 5. And we're not going to leave it like that. We're going to split it. 1/5 minus 2/5 I. So that if you were to plot that on a grid, like the front page of your pink homework has, you were going to know exactly to go 1/5 to the right, negative 2/5 down. You would know where it would go. Okay, next. Verify that 1/5 minus 2/5 I, which is our answer to the previous one, and 1 plus 2i, which was the thing we said was its reciprocal, verify that they are indeed reciprocals. And you may say, well, we just did that. I did 1 over 1 and showed it was the other one. True, but when I verify numbers are reciprocals, the check is not that if I flip one, I get the other. The check is that when I take the two of them, 1/5 minus 2/5 I, and I multiply that by 1 plus 2i, what should I get? 1. A reciprocal is a number that when I multiply it by the other number, you get 1. So this should get 1. I should get 1 from here. If I get anything other than 1, it was not a reciprocal. First, 2/5, outer, plus 2/5 I, inner, minus 2/5 I, last, minus 4/5 I squared. I think you can see that the imaginary parts cancel each other out. I squared replaces with negative 1 to give me 1/5 plus 4/5, and 1/5 plus 4/5 is 1. Okay, let's practice some more. We're going to factor 10x squared plus 1. Now, it doesn't factor the way that you guys would want, so we're going to factor it as a difference of 2 squares. Which means that before I do that, I need to write it as a difference. It's a sum right now. Can I stick a minus sign in there? Minus negative 1, which is the same as saying minus I squared. Now, I know the 10 is not a perfect square either, but that's okay. We're still going to factor it as if it were, because the square root of 10 is the square root of 10. Radical 10, x and x, minus I, plus I. Every single binomial can be factored as a difference of squares, and I'll prove that to you with an even more extreme case. That's it. We're going to factor x plus 7. Just a simple, regular binomial that by no means should factor, but think about this like you're revealing a deeper layer of this. I'm going to write this as x minus 7i squared. And what am I going to pull out for the first part of these? Square root of x, minus square root of 7i, with the I outside of the radical, plus square root of 7i. So just about everything can be factored with a difference of squares. Next. Oh, we got to play more, guys. Hang tight. Hopefully, if you stop asking me that. 2x plus y plus x minus y. You didn't raise your hand. Yeah. If your eye isn't what? Well, make it look like an eye. All right. For this kind of problem, we need to look at the real part of the left side and the real part of the right side. So what I'm going to do is I'm just going to ignore the non-real part and just look at the real part of the left side. And the real part of the left side is the part that doesn't have an I in it. What's the real part of the left side? 2x plus y. Okay. I have 2x plus y, and that's the real part of the left side. That is this thing. What's the real part of the right side? What should be true about those two? They should be equal to each other. The real part of the left side should be equal to the real part of the right side. Think about corresponding parts should match each other. The imaginary should also match. Can you give me a second xy equation below this that would show that the imaginary parts are also equal? Hannah? I'm going to make it even simpler. I'm just going to say that x minus y is equal to -1. Remember, this right here, no, x, this represents the ordered pair 4, -1, right? Yeah. And this up here would represent the ordered pair 2x plus y, comma, x minus y. So the left parts should be equal to each other. And these right parts here should also be equal to each other. The I is an indicator. It's nothing more really than an indicator. I know we use it in math a lot. But when you're writing a complex number, it's telling you which part is the imaginary part. Yes, Hannah? Why is it -1? -1 is the coefficient of this. Well, again, what's the coefficient of I right here? X minus y, right? What's the coefficient of I here? I know. What's the coefficient of I right here? -1. So we're saying that the x minus y has to be equal to the -1. Okay. Guys, how would you do this? Yeah, I'm going to add them. Because I have 3x equals 3. Oh, I didn't see that. I'm solving the system. And x is equal to 1. Yeah, I'm going to plug it in right here. 2 times 1 plus y is equal to 4. So y is 2. And so my solution set is the ordered pair 1, 2 for x, y. So it's a different way of asking a system. Okay. We're going to do a grand finale problem here. Well, Ben's going to want to see this one. No. 2 minus root 3 plus 1 minus root 2 I. We're going to take this complex number, which that complex number is already simplified. You can't do anything with it. The 2 minus root 3 is the real part. The 1 minus root 2 is the imaginary part. But we're going to take this and we're going to square it. You can't distribute a square across addition and subtraction. I don't know how to do it. Why don't we try a method that you guys have been using to make things just a little bit easier for a second? Why don't we let a equal 2 minus root 3. And we're going to let b equal 1 minus root 2. So what I get is I get a plus bi squared. And we can deal with that separately for a second. This would be a squared plus 2abi plus b squared I squared, which is the same as, well, what's b squared I squared? So I have a squared minus b squared plus 2abi. And a squared minus b squared, I know we can factor that, but our goal is to simplify. So now it's time to plug everything back in. Because that's the real part. It doesn't have an I on it anymore, so that goes together. And the 2ab is also going to go together. So a squared is 2 minus root 3 squared. B squared is 1 minus root 2 squared. This is all in parentheses. Plus 2 times A times B with a little I after it. Yes, Carson?
So did we get that minus b squared because I squared is negative?
Because I squared is negative 1. So now we're going to actually have to simplify all this out. 4 minus 4 root 3 plus 3 minus parentheses 1 minus 2 root 2 plus 2 plus, now we're going to simplify this, 2 times first minus 2 root 2 minus root 3 plus root 6 and I. And just so it doesn't become too complicated, let's add those. This is 7 minus 4 root 3. Let's add this and kind of move it inside. Minus 3 plus 2 root 2 plus, and we're just going to distribute that 2 here on the right. 4 minus 4 root 2 minus 2 root 3 plus 2 root 6, all in parentheses with a little I after. And the only thing I can do now is just add whatever's in here to get 4 minus 4 root 3 plus 2 root 2 plus 4 minus 4 root 2 minus 2 root 3 plus 2 root 6 I. And that is done. I know because the real part can't be simplified and the imaginary part can't be simplified, but they've all been kept separate from each other. You have a real part plus an imaginary part. Now I'm going to hear them complain, Ben.